Good. All right. My notes say that we ended at 21, but
Okay.
I kind of feel like I was guessing. I'm not sure. Actually, I don't remember doing 21. I kind of remember doing 20. Do you remember?
Yeah, we did 21.
We did 21.
Yeah.
All right. All right. Let's go to 22. Now, I definitely do not remember this. I am tutoring quite a few SAT students, and you're out in front of the pack. So if I see a problem I don't recognize, it's most likely you.
Okay.
In other words, you and I are going through it a little quicker than my other students.
Oh, I guess that's good, right?
Well, yeah, it's neither good nor bad, really.
Yeah.
Um, it's just you're doing it once a week, and some of them are doing it once every couple weeks.
Ah, that makes sense. Yeah.
Yeah, that's, in other words, that's as good as explanation
Right.
as any. Um,
Yeah.
but yeah, no, if you were doing it exactly the same amount of time and you were further along, that would be better for sure.
Yeah.
All right. So 22 and 23 refer to that table.
Okay.
What's the first thing you're going to look at on that table?
Uh, probably the
The,
programs and.
the title. Always
Oh. Okay.
look at the title. That tells you an enormous amount of information. It really does. In other words, that kind of tells you everything that you're looking at in this table. Again, this would be a question you would find on the science section of the ACT. But once you see the title and you understand the title, then everything you're looking at makes perfect sense, right? Okay.
Right.
So, question 22. Do I need to blow that up at all? Can you see it? I'm afraid if I blow it up too much, you won't be able to see the table. But, so for the moment,
Yeah, I can see all right. Yeah.
okay, cool.
Okay.
Let's make sure you notice keywords when you read these questions.
Okay.
That is a keyword. That's
Yeah. Yeah.
Those are the four or the three keywords that are going to allow us to. And if you miss one of them, you're going to get it wrong. You got to notice all of them. So
Okay.
we're not looking at the total budget. We're looking at just the change in that budget from that
Okay.
year to that year.
Yeah.
Do you have your calculator in front of you?
Yeah, I do.
Tell me what that change is. Actually, just look at the answer. Hold on a second. There was another key word that I missed. Let's just stop for a moment and go back and look
Okay.
at the chart
Okay.
right there. These aren't absolute numbers. These are in numbers that are in thousands of dollars.
Right.
It means that this 358 is actually 358 million.
Okay.
Okay? So this is an extremely important keyword, and I didn't notice it until I looked at the answers, and the answers didn't fit anything. So I realized that, wow, I must be missing a key piece of information. And sure enough, I was. Every number you see in there is in thousands of dollars. So,
Okay.
what's the answer to 22?
D.
Yeah. In other words, the difference between 488 and 358 is 130, if you just kind of look at the approximate difference.
Yeah.
It's not.
I didn't even think to look at the bottom of the table there.
What's that?
I said I didn't even think to look at the bottom of the table there that showed that.
I did not either, but that's a good lesson. There's frequently key information that's whatever information they're putting on there, and I can't say that it's always key, because both the SAT and the ACT like to trick you. So there are going to be some questions where they give you information and it's not relevant. Okay? In cases of tables and charts like this, almost everything they give you is relevant. So it's really important. And if I were taking the test, I would absolutely underline stuff like that. You can mark up your booklet as much as you want.
Okay.
Okay, and the thing is that once I've underlined stuff, circled stuff, now I know what to look for. How about 23? What do you have to answer first on 23?
You have to look at the human resources program ratio first and determine that.
You got to know what that is. So let's figure out what that is. From 2007 to 2010, what percentage difference? Increase or decrease? What are we looking at? Use your calculator. This is definitely a problem where a calculator is going to help. Although, I'll bet in the end, it doesn't. You could do this in approximate mode, and I'll bet you get it right. That's close to 50%. What is it exactly?
Let's see, and then
Take the difference, divide by the original.
yeah.
We'll see if my approximation method works as good as the exact numbers.
Okay. Yeah, you're close. It's about 46%.
Okay. Now, basically, we have to figure out all the others. In other words, which one is closest to 46%? Well, we don't have to do the math if we can look at it immediately and decide. Is that close?
No.
Go ahead and use your calculator. I'm going to, again, do an approximation. I'm going to say that that's about 36%. Just in my head. What do you get when you do it? No, 32%.
30%.
What is that?
It's no, that's right.
488 minus 373 divided by 373.
Yeah, no, I think it looks like I'd round it up to about 31%.
Okay. Number 2. Unfortunately, this is really a long problem because we have to analyze all the others. Well, do we really need to analyze all the others? No, we can forget one of them, but we got to do 4 of them. So what's education? In my head, I'm going to say that's like 45%.
Okay.
What is it? I want you to tell me exactly.
Yeah. Okay.
We don't know how close the numbers are going to be. In other words, we may be able to get away with approximation. We may have to get the exact number.
It is 38%.
Okay, I was quite a bit off there. And let's see, the next one, highways and notice we don't need to do general government.
Mm-hmm.
And we can see instantly that that wouldn't be an answer anyway. But
right.
Highways and transportation, what do we get? In my head, 300,000 divided by 1.4 million, that's less, that's like 28%. I can rule that out. I don't even have to know the exact one.
Okay.
That's not as close to 46% as the previous one, which is 38%. And there's no way that's even close to 38%. So how about public safety? Ooh, that's quite a bit. That's like 200 divided by 263. What is that? What's 200 divided by 263? You don't really need to worry about these numbers here.
Okay.
You won't. You'll see why. What's 200 divided by 263?
76%.
What's our answer?
Not that one.
We want the one that's closest to 46%. Which is it?
Wouldn't that be education?
Yeah. But look at how much time it took us.
Yeah, that's longer than a minute.
Well, the question is your calculator faster than the estimator? Notice that the estimator was plenty accurate. The estimator allowed me, I didn't need a calculator to answer this problem. The moment I got that number right there, and I knew this was like plus 66 or something, I have my answer. So I don't need exactness for this kind of a problem. Now,
right,
it kind of depends on your math skills as whether or not you can come up with the exact number faster than you can do an approximation. You might be able to. So if you are really, really dependent on your calculator, then go there immediately. But even with the calculator, you notice you don't need these last 3 digits. You can just take 488 minus 373 divided by 373. That gives you your number. Now, it's not exact, but you can see that we don't need to be anywhere near exact. And that's always the case. They don't put 2 answers. In other words, they're not going to give you 45% and 47%. That would be too confusing. Okay? So if the correct answer is 46%, you can bet that only one answer is going to be anywhere near that. There's not going to be multiple answers near that.
Okay, yeah, that sounds good.
Okay. And that's also kind of typical of calculus. Whenever they're allowing you to use the calculator, well, they're usually giving you problems where you have to divide 3 digits by 3 digits or something like that. In other words, they're not going to allow you to use the calculator if you have to divide 16 by 4.
Right.
All right. So 24.
Oh, and then for this one, and then can I go back to the page where it shows all those formulas?
Unfortunately, I do not believe they give you the formula for the equation of a circle. Let's go look. You might be right. They might, but I don't think they do. No, they don't. A circle is a conic section.
Yeah.
And you have to memorize it, okay? So you don't have to memorize a lot of conic formulas. There's like 4 of them. You know, you have circles, you have parabolas, you have ellipses, and you have hyperbolas. Well, circles are the most complicated thing they're going to give you. So the one equation you absolutely have to memorize is the equation of a circle, the general equation of a circle. And let's talk about that because it's really easy. This is a super easy. Well, they add something extra, as they always do. But let's start with the equation of a circle. And if it's a circle at the origin, it's just x squared plus y squared equals the radius squared. Very, very simple. And this is really what you should start with when you're trying to memorize this.
Okay.
Okay? That's if the center is at the origin, like that.
Okay.
Okay? If the center is someplace different than the origin, like that, then the equation gets a little more complicated, but not by a lot. It just becomes x minus h, where h is the x coordinate of the center, plus y minus k, where the k is the y coordinate of the center. Everything else is the same.
Okay.
Okay? So, they give us the center.
Yeah.
So, let's do at least this part. That part's really easy. And look at your answers. Always look at your answers. Notice that the answers are in the form of our general equation. It's just got specific numbers plugged in. Okay? So, let's see if we can figure out the left side.
Okay.
Left side's easy.
I think the left side is x squared plus parentheses y minus 4 parentheses squared.
Okay, that's definitely the left side. Now let's examine our left side and see how many of these we can get rid of. Well, we can get rid of that one, and we can get rid of that one. So if you're about out of time, you would at least have a 50-50 guess here.
Okay.
Okay? So we have to figure out the radius. And that is a whole nother issue. In other words, in addition to knowing or having to know the equation of a circle, you got to know the distance formula.
Okay.
Okay? The distance between 2 points on the xy plane. Notice that that's just the Pythagorean theorem.
Yeah.
It really is. That's the hypotenuse.
Okay.
Okay? So, now, I'm going to give you a tip. Remember what our distance formula or our circle formula was. We didn't need r. What we needed was r squared. Well, r squared is going to be this distance squared, right?
Yeah.
So I can make it a lot simple by squaring it first, eliminating the radical sign, and what I'm left with is this.
Okay.
And that's much easier. So what's x sub 2 minus x1?
Let's see. So 5 minus 0.
X sub 2. That's x sub 2.
Oh, sorry. Yeah. So 4 over 3 minus 0.
Okay, square that. What's 4 over 3 squared?
That would be 16 over 9.
Okay. Plus, what's the difference in the y's squared?
5 minus 4, so just 1.
Okay. Now, if we look at our two allowable answers, which one is that number? Yeah, excuse me, I wrote over. I didn't need to do that. That was 16, yeah. Is it 25/9 or is it 5/3?
25/9.
You got it. In other words, 16 over 9 plus 1, which we turn into 9 over 9, gives us 25/9. Again, not really a hard problem if you know that formula. That's critical. Don't forget that formula. You're going to need it. And you need the distance formula. The thing about the distance formula, let's just talk about it. If I have a point there and a point there, well, the distance between them is always the hypotenuse of a triangle that I can draw, right triangle. And this distance is just the difference in the x coordinates. So that's delta x. This distance is the difference in the y coordinates. So apply the Pythagorean theorem, and delta x squared plus delta y squared equals distance squared. And that's how you get this distance formula.
Yeah, it's just like Pythagorean theorem, yeah.
It is. And as long, a lot of people have trouble with this because it looks so complicated. I mean, the square root of x sub 2 minus x sub 1 squared, people don't like memorizing that. But if you think of it as the hypotenuse is the square root of one side squared plus the other side squared. That's the formula for the Pythagorean theorem. And there's one side squared, there's the other side squared. All right, 26. Oh, no, hold on. Let's go in order. I don't want to, otherwise I'll forget. Let's do 25.
Oh, I remember doing these.
This easy, medium, or hard?
Medium.
Barely. It's actually pretty easy.
Okay.
You just have to know what each variable means.
Because I remember doing these not too long ago. I said I remember doing these not too long ago in class.
Yeah. T is the number of seconds that elapse.
Yeah.
Once you understand that, then okay, approximately how many seconds will the ball hit the ground? Well, what's the height when it hits the ground? What's the height of the ball when it hits the ground?
Oh, 0.
So I'm going to make 0 equal to minus 4.9 t squared plus 25t. And now that's the equation that governs this problem. Okay. That 25 is already in that equation. That's where that 25 comes from.
Right, yeah.
So the only thing we have to do is, oops, excuse me, there's a t squared there.
Oh, yeah.
Okay. So the only thing we could back solve this.
Yeah.
In other words, let's just pick our numbers and solve it. But I'm not sure that back solving, that's a lot of calculations to make, right?
Yeah.
Maybe we can actually algebraically solve this a little easier. If I were trying to algebraically solve that, what's my first step? Think greatest common factor. What's the greatest common factor out of that? I don't have to factor it. There's no constant. But I do need to factor it using the greatest common factor. It's t.
Okay.
I can take a t out of both expressions.
Oh, okay, yeah, that's true. Okay.
That leaves negative 4.9 t plus 25. Okay? Now, the most basic rule of algebra. How do you solve that?
So I'd subtract 25 from one side and do the other.
Hold on. When I say the most basic rule of algebra, what I mean is if you have two things multiplied together that equals 0, your solution is to set each one of them equal to 0. So either t is equal to 0 or minus 4.9t plus 25 is equal to 0. Well, that means that it's on the ground when it starts. Okay, so when time is 0, the ball is on the ground. But we're going to throw it up in the air and we want to see when it comes back and hits the ground. Well, that's going to be the solution to that. Solve that as quickly as you can and tell me what the answer is.
Okay.
Using your calculator if need be.
5.1.
Correct. That means that's the answer.
Yeah.
Okay. And again, do not forget this principle. That truly is the most important rule from all of algebra. If somebody question you, what is the single most important rule in algebra, that's it. If you have multiple things multiplied together that are equal to 0, then one of those things has to be 0. You cannot find two numbers that multiply together that are equal to 0. They don't exist unless one of them is 0. So that's how you solve these problems. And that's the whole reason you set quadratics. That's a quadratic. That's why you set them equal to 0. Is so that you can then factor them and solve. Now, did I need a calculator? Not really. I got minus 25 divided by minus 4.9. Well, I know that 25 divided by 5 is 5. I'm dividing by a number smaller than 5. I got to get a number bigger than 5. It's 5 and change. I don't care what the change is. That's going to be the closest answer. It could be 5.1, it could be 5.9, I don't care. Once I know that it's a 5 plus, I got my answer. So again, don't need a calculator. It might make it a little easier for some people, but there are really very few problems on this test that you actually need a calculator. Let's look at 26. If I can. All right, go ahead and read it.
Oh, okay.
Tell me what the best way to solve this. First of all, is it easy, medium, or hard?
I'd say easy.
What's the best way to solve it? Algebraic, back solving, or picking numbers?
Maybe picking numbers.
No, you only pick numbers when there's variables in the problem and variables in the answers. And we don't see any of that. There's no variables anywhere.
Could you write an algebraic expression and then try to do that?
That's algebraic. I personally feel that back solving is the best way to do this. Okay? In other words, and when you back solve, don't start with A. Start with B. Always.
Okay.
So we're going to assume that 120 is the correct answer. Well, let's see. What should we multiply 144 by if it produces 20% more than type B? Then what should we multiply 144 by to see what type B produced?
Well, could you also, could you just do like, for example, like 144 minus 120, get the number, then divided by?
How about we multiply 144 by 0.8? That's what a 20% increase means. Hold on a second. No, it doesn't. No, it doesn't. Just one moment. Let me think about that for a second. We're going to take this number, we're going to multiply it by 1.2. And if that gives us 144, we have our correct answer.
Okay.
So 12 times 12 is 144. So when I multiply it by a 20% increase, okay, the lesson with this problem is, do you do it in 2 steps or 1 step? Well, I can take 120, multiply it by 0.2, I get 24, and then I can add 24 to 120 to get 144. Well, that fits. That's the correct answer. We know that's correct. But I can save a step here by always recognizing that when something is increasing by 20%, then instead of multiplying it by 2 or 0.2 and adding it, let's just multiply the 120 by 1.2. That is an increase in 20%. That gives us in 1 step 144. That's what she has. That's the correct answer.
Okay.
Notice I did not have to fool with algebra.
Yeah.
Really. If I would have had to fool with algebra, then I would have had to say something like, okay, x equals the number of type B trees. And I would have said 1.2 times x has to equal 144. and then x would have been 144 divided by 1.2, which gives us 120. So there's the algebraic solution. Much harder. Much harder. And it always is. People don't tend to think of algebraic equations when they think problems. But if somebody gives you an answer, let's say you're the owner of this tree farm, and it matters to you in your pocketbook, and somebody says, okay, is 120 the answer? Well, you know that you're going to take 120 multiplied by 1.2. And if it equals 144, then you say, yes, everything's copacetic. If it doesn't, then you say something's wrong here.
Mm-hmm.
So everybody knows how to solve this problem. It's just not everybody knows how to algebraically formulate it. And therefore, don't do that. In other words, when you see problems that are best solved by back solving, do so. Back solving is one of the most valuable things. And when I talk about picking numbers, then picking numbers always goes with back solving. So there's really three methods. There's algebraic, there's back solving, and then there's picking numbers and back solving. You don't just pick numbers, you do both. Okay? This part requires variables. In other words, I need a P or an A, whatever the other type is, two types of pair trees. Okay. So I need a P sub A or a P sub B. Those are my variables. But why go through the algebra? That's hard.
Yeah.
Back solving. I don't have any variables in my problem or my answer, so I can cross that one out. You never pick numbers unless you have variables that are in both the question and the answer. So I'm going to have two choices here, algebraically solve it or back solve it. Back solving, if it works, it is always the easiest method.
Okay.
Now, sometimes you kind of have to get used to what lends itself to back solving and what doesn't. But after a while, you get so you recognize when back solving works really well. Number 27. I haven't ever seen this problem, okay? And the fact that I'm looking at 8 sentences and a table, this is an easy problem. Seriously. Now, the fact that they're giving you so much information, they give you that, they give you that, they give you that, they give you that. Okay, it's going to be a complicated problem, but it's still, if your life depended on it, you'd pick this problem. You'd say, I know how to do that. I haven't even looked at it yet. And I would almost gamble my life that I know how to do it.
Okay.
Just because they're giving us everything we're going to need. I can tell that. We just have to figure out how to apply it. So let's look at the question first. Just because the paragraph is so long, let's look at the question first. It's the number of earthworms to a depth of 5 centimeters. Each of these regions is a different depth.
Mm-hmm.
So now let's read the problem.
Okay.
Well, I'm confused a little bit, and I'll show you why. There's our square field,
Mm-hmm.
and they say only 10 students mark off randomly selected regions, and each region is a square 1 meter by 1 meter. Well, notice I could fit 100 of those in there.
Mm-hmm.
When I have 10 meters by 10 meters, I can fit 100 squares in there. I can fit 10 rows, 10 columns.
Yeah.
So when they say they're random, it's like this. There's only 10 of them. So that's what we're looking at.
Yeah.
Okay, and they're just kind of trying to get a probability distribution of where the worms are.
Okay.
So those are my regions. Now, I don't have to go to this much trouble when I'm drawing a general diagram, but it's helpful sometimes, especially if you have enough time. If you're squeezed for time, then you're not going to be able to do this method.
Okay.
So, what are they asking? Every single region is 5 centimeters down. So they're all equal compared to that. Okay.
Right.
So what is a reasonable approximation? Well, isn't it the average of those 10 numbers?
Yeah. I just started adding them up right now.
Well, hold on. Before you do that, don't do that. That's a waste of time, just like my picture was a waste of time. Look at the answers. Tell me what the answer is.
A.
Has to be. In other words, this was a no-brainer. This was not even close. It's not like they put 150, 152, 148. They didn't give us answers like that. If they'd have given us these 4 answers, then we would have had to add up all those numbers and divide by 10. But the fact is, they gave us a no-brainer as long as you understand the question. This is all about understanding the question. And in order to understand the question, it really kind of does require you to read it and look at the question. In other words, you can't do this in 5 seconds.
No.
So once you understand the problem, you can do it in 5 seconds. But you have to understand the problem. Okay? But again, a problem that has a huge paragraph and a big table that's going to be on the science section of the ACT. But just looking at that and that, I knew it was an easy problem. Automatic. In fact, seeing the length of that and the length of that, I would have bet my life I could answer this. That's how confident I am that it's an easy problem.
Okay.
Okay? The hard problems are the shorter ones, really.
Yeah, that's true.
Okay, let's go on. All right, now let's see how many there are here. We're still in the, okay, we're right at the end of the section before the grid section comes up. So we're definitely dealing with the harder problems if they go easy to difficult. And I had to look at that because I didn't know whether we were near the end or the beginning. In other words, the SAT is 60 questions. And each section, I think it kind of goes from beginning to hard in each section. So just because we're dealing with question 28 doesn't tell me much. I had to know whether we were towards the end or the beginning. We're towards the end. There's only 32 questions here before we get to the grid question. Okay? So let's look at 28. Okay. To be able to answer 28, you have to know how to graph inequalities, and you have to know where to find your solution set. So let's go through that. I think it's worth going through it.
Okay.
We have enough time to go through it. Tell me how to graph this. Hold on. And that is always, understand that when you have two inequalities, there is no numerical answer. There's only a graphical answer. So you absolutely have to put these lines and shaded regions on the graph. So first of all, let's graph that. Where do I start?
Well, so y is greater than or equal to 2x plus 1.
That's y equal mx plus b format.
Yeah.
So start at the b.
Okay, so slope is 2 over 1 then.
No, the b is the y-intercept. Here's the formula. Y equals mx plus b. That's the y-intercept. That's where you start. Then you apply.
Oh, okay. Yeah, so y-intercept is positive 1, so.
I'm going to call that 1.
Yeah.
And I don't need it to be exact. There's no grid on this thing. It doesn't have to be exact. What's my slope?
2 over 1.
Okay, so I'm going to go up 2 spaces over 1. That's a pretty good slope. Am I going to draw a solid line or a dotted line?
Solid dotted.
Solid, because it's greater than or equal. Now, which side of that am I going to shade? Above or below? And it's always above or below. It's never left or right.
Right.
I want your eyes to look above and below, not left or right. So tell me whether I'm above that line or below that line.
Okay. Above that line?
Yeah, because of that. It's real easy. That says greater than, you're above. If it says less than, you're below. So I'm in this territory for the solution to the first inequality. Now, let's look at the second inequality. Graph that for me. Where do I start?
Start at y-intercept of -1.
Okay, right there. Here, let me use a different color. And apply the slope.
Slope is 1 over 2.
Okay, so if I go up 1 to the right 2, it's not 1 over 2, it's up 1 right 2. Because over could be left or right. And the slope is very important, whether it's positive or negative. Well, if I connect those two dots, it's a dotted line, but that's not really going to make much difference. It's going to tell you there's our solution right there. In other words, wherever those two, oh, excuse me, hold on. I'm sorry, I was thinking equations. These inequalities. Yeah. Which side of that blue line am I on?
The upper side.
Okay, so this side here. So that makes my solution wherever the two are together, which is that area right there, right? In other words, that area right there is in both equations. And that's what you do, is you find the area from each inequality, you shade it, and wherever your shading is there, it notice the question.
Yeah, no solution.
Well, that's not what I thought the question was. I thought the question was, which quadrant is it in? It's not. It's which quadrant has no solutions.
Right. So wouldn't that be, was it 4?
Yep. Because there's a solution in 3, there's a solution in 2, and there's a solution in 1. But there is no solution in that area. There is to one of them, there is to the blue line, but not when you consider the red and the blue. There is no solution in quadrant 4. So this actually was difficult only, well, you have to know how to handle a system of inequalities, which was what this was. And basically it's pretty straightforward. You graph each inequality as if it were an equation,
Right.
and then you pick one side or the other to shade. And then where you have common shading, that's your solution.
Yeah, it's pretty easy.
Yeah, it is. And whether it's a dotted or a solid line didn't really matter to us in this problem. Notice that it didn't matter at all. Quadrant 4 did not have a solution, whether that would have been two solid lines or two dotted lines. Their intersection is the important point. Well, not their intersection. The common region is the important point.
Okay.
Let's go back and do, what happened to 29? I got a 28. Oh, it must be down below. All right.
Oh, there it is, yeah.
So let's see if we can do 29 in the remaining time. Now, knowing these are the hard problems, but that problem wasn't so hard.
Yeah.
You just had to know how to graph inequalities, and that's definitely something you've learned in algebra.
Right.
All right, let's look at 29. Easy, medium, or hard?
Easy.
No,
Medium.
I don't think so.
Really?
Yeah. I think hard. And notice that the problem is only 2 lines long.
Yeah.
But we're at 29. We've only got 2 more problems before we get to the next section. So we're in the hard section. In other words, what they're saying is this. There is some polynomial. Let's just guess at a polynomial. If I say f of x equals, well, let's call it p of x. That's what they're calling it. So if I say p of x equals something, let's say x squared minus x minus 2, okay? And what they're saying, I'm making up this polynomial. We don't know what the polynomial is,
Right.
okay? But what they're saying is p of 3 equals minus 2. That means if I plug in 3 for x, I get minus 2.
Right, yeah.
Which of the following must be true about the polynomial? That is a factor? Wow. That doesn't help me. That's a factor? That doesn't help me. That's a factor? That doesn't help me. The remainder is that when I divide it by that. That doesn't help me. This is a hard problem for me.
Oh, okay.
Got to think about this a second. On the polynomial that I made up, is p of 3 equal to minus 2?
9 minus 6. No.
No, it's not. What if I add a 3x right there? Now is p of 3 equal to minus 2?
Yeah.
Yeah. So I figured out how to create a polynomial where p of 3 was equal to minus 2. The problem is the polynomial I created doesn't have any factors. That doesn't factor nicely. That requires the quadratic formula. So can I rule out that that. Not necessarily.
Yeah.
But, you know, if I'm at the end of the test and it's time for guessing, it's guessing time, I'm going to guess this.
Okay.
Because the polynomial, the one polynomial that I could think of that fit their conditions doesn't factor. In other words, that's not x minus 2 times x plus 1. Which means none of A, B, C, or D could be true. Certainly not if it's this polynomial.
Yeah.
Which means D has to be true. There's a remainder. That means that it's not divisible by that. There's a remainder of minus 2 if you divide by that. Now, do I take the time to take the polynomial that I made up and divide by x minus 3 and see if I get minus 2? No, I don't take that time.
Okay.
I'm immediately going to assume that because I made up a polynomial, it fits their conditions and it does not factor, that there are no factors for it. Now, could it be possible that I could make up a different polynomial? Well, if I examine some of those factors, in other words,
You just
x
back solve and put in those
5,
factors.
let's assume x minus 5 was a factor. Could I make up something here? I can't put anything there. I don't know. This is a really hard problem.
Like you're trying to like, aren't you? Because now you're like, I mean, if you had more time, granted, true, but you're at the end of the test and it's a hard problem, maybe not. That you would just try to implement all those factors and see if any of them were able to work, and then if not,
It
then
depends on how much time. If I had
Yeah.
15 minutes to do this problem, then I might go through these steps here to see if I could find a polynomial that has a factor of x minus 5 and something else such that p of 3 was minus 2. That is going to take a lot of time. To be honest with you, I kind of like my first step, or the way I did this, is I found a polynomial that I made up and realized that there are no factors of that are not irrational. In other words, there's always going to be a remainder. You're not going to find two factors that multiply to that. I've done enough practice factoring to know that. And when I see a problem like this, I got to use the quadratic formula. Well, if I got to use the quadratic formula, then I don't have a simple factor like that, and which allows me to eliminate A, B, and C. So I choose D and go on. That's to handle really, really hard problems.
Okay.
Go ahead, and if you just don't have a clue, and this could easily be a problem, this is a kind of problem where you might not have a clue as to how to start it. I made up a polynomial, that's one way, and even that wasn't that great. But it was a way I could proceed. But if you don't have a clue, mark a difficult on it and guess. At this point, if you're usually when you get to this point of the test, you're about out of time. You don't have a whole lot of time to give to this problem. Even if I don't want to go through my analysis of making up a polynomial, I'm just going to guess. Maybe I'll guess that one there, but I'm going to guess. Okay. If I had 5 minutes and this was the only problem I had left, then I'm going to go through the analysis that I did. I'm going to try to find a polynomial where that is true, and then I'm going to see if it factors. And when I saw that it didn't factor, then I choose D with a lot more confidence. It's not a pure guess.
Yeah, sure.
Okay. Yeah, I'm sorry I've run you over by a few minutes. I will mark 29 as our last one that we did, and we'll pick up next Saturday.
All right, sounds good. Thank you.
All right, bye-bye.